Ever pondered the importance of probability in our daily lives, or how we can predict future events based on prior knowledge? It's a fascinating realm of mathematics that has been explored for centuries, and at the heart of it is a theorem named after Reverend Thomas Bayes. Welcome to the world of Bayes' theorem. In the mid-18th century, Thomas Bayes, an English statistician and philosopher, introduced a concept that would revolutionize the field of probability and statistics. This concept, now known as Bayes' theorem, was actually published posthumously in 1763 after being polished by another mathematician, Richard Price. The theorem itself is a statement about conditional probability. It provides a mathematical framework for updating probabilities based on new data. In simple terms, it helps us to revise existing predictions or theories given the reality of new evidence. Now let's delve into the proof of this theorem. It's not as daunting as it sounds. The proof starts with understanding two fundamental concepts: conditional probability and independence. Conditional probability is the likelihood of an event given that another event has occurred, while independence refers to events that do not affect each other. The proof of Bayes' theorem is actually a straightforward consequence of these concepts. It's derived from the definition of conditional probability. If we have two events, A and B, the probability of A given B is the probability of A and B happening together divided by the probability of B. Similarly, the probability of B given A is the probability of A and B happening together divided by the probability of A. The formula rule of Bayes' theorem is then a simple rearrangement of these definitions. It states that the probability of A given B is equal to the probability of B given A times the probability of A divided by the probability of B. Now, where does this theorem come into play? It finds widespread application in diverse fields. In medicine, for instance, it is used to calculate the likelihood of a patient having a disease given a positive test result. In machine learning, it helps in updating predictions as more data becomes available. In essence, Bayes' theorem is a powerful tool that allows us to update our beliefs based on new evidence. It's about learning from experience, which is something we all do every day, whether consciously or not. As we wrap up, remember that Bayes' theorem is a fundamental concept in probability and statistics. It provides a mathematical framework for updating probabilities based on new data. The proof of the theorem is straightforward, derived from the concepts of conditional probability and independence. And its applications are vast, from medicine to machine learning, impacting our lives in ways we might not even realize. So the next time you make a prediction or update your beliefs based on new evidence, know that you're in the good company of Reverend Thomas Bayes and his revolutionary theorem.